Okay, so now let's talk about some basic concepts on rivers. And let's start with this hydrologic cycles. I think it's just a quick reminder that hydrologic cycles represents a complete cycles of water on the surface as well as near the surface of the earth. Usually, when we talk about hydrologic cycles, we start with the ocean, where we have, of course, we have lots of water over there. Evaporation can occur in the ocean, creating water molecules in gas phase and creating, say, cloud formation, right? And the clouds can travel towards the land, and then we have precipitation in a form of rain and snow. And when this water molecule touches the ground, it can actually have two options. It can be part of the surface runoff, or it can go through a further process which is called infiltration, where these water molecules goes into the ground and become part of the groundwater. Okay. In this module, we're going to focus mostly on surface runoff, the processes involved in rivers, or any other types of flow of water on the surface of the earth. However, we're going to talk about groundwater, and we're going to discuss groundwater resources later on in the next module, I believe. So stay tuned on that. Both the surface runoff and groundwater flow, and they both will eventually end up here back in the ocean, completing its cycle. Surface runoff starts out with sheet wash. Sheet wash is a very thin layer of flow of water on the surface of the earth, and it covers, of course, the ground. And then sheet wash can actually lead the formation of sheet wash can actually lead into a more concentrated flow of water, creating new channel that is illustrated by this second picture here in the middle. The flow of the water will start to erode and scours the channel even more, creating even a deeper channel, and eventually evolve into what we call as streams or rivers. Um, Another thing that you need to know is about headward erosions. This process actually allows the channel to erode towards its upstream direction right here. It lengthens the channel or the streams, and it also creates and it forms distributaries along the head part of the channel, and eventually creating what we call as drainage networks. And this is something that I'm going to mention in the next couple of slides. But before we talk about drainage a network, let's talk about some basic term first: streams versus rivers. What are the difference between them? Well, basically streams are generally much smaller than rivers. Okay, and it's a body of water flowing in channel confined in beds and banks. Rivers are basically, generally it is larger water course, and of course it usually has fresh water, except when it's very close to the ocean. But eventually, the waters that are in the rivers will end up in the ocean. Okay, whereas the water that we have in streams typically end up in bigger rivers. Okay, so I mentioned about drainage basins before. So drainage basins or watershed, okay, it's basically a region drained by a single river or river system. It actually the place or the areas that catches water, okay, and driven or governed by a river system or a major river system. So, for example, here in this picture, we actually have two drainage basins, one on the left, right here, okay, and the other one is on the right side, okay. And these two drainage basins that we see in this picture is divided by something that we call as drainage divide. Drainage divide is an imaginary line that connects the highest point of both of the drainage basins. Basically, it separates the two regions from each other. Okay, and these regions again will define where the water will flow. So, for example, if we have rains right here, right? Every single drops of water that falls into the right side of the yellow line will become part of this drainage basin here on the right side, whereas all the water molecules that fall on the left side of this yellow line will become part of the drainage basins on the left side. As simple as that. We do have examples, of course. Every regions have their own watersheds. Here, in our local area, we have multiple watersheds. One of the major one is the Delaware River watershed, which is located here in the eastern part of New Jersey. Delaware River starts from here, and along that river, every color that you see here on the left side of this pic of your screen right here, it represents the different types of the different locations of Delaware River watershed. Okay. And not only that, if we zoom out a little bit and take a look at the continent in a broader sense, we actually can have one and maybe two, and then another one here, three major watersheds that are located in the United States. Actually, we have another one here, the fourth one right here, right? So, for example, if you take a look at the center part right here, this is the Mississippi River watershed, one of the biggest, one of the largest watershed in the world that covers almost, the entire middle section of the United States. And if you notice that every single arrows that you see here, except the ones that are located right there that I'm highlighting right there, every single arrows that you see there, they all flow into the ocean except for those in Great Basin. Great Basin is an anomaly watershed where it actually doesn't end up in the ocean, but it actually collects water right in the middle section of that basin. All right, so again, like I said, sometimes rivers do not reach the oceans, like what I show you there in the Great Basin in the western parts of the United States. All right, another basic concept that I want you to know about rivers is the stream profile, okay? So what do I mean by stream profile? It's basically a cross-sectional view of the morphology of the river. So if we take a look at the river and see it from the side, typically this would be this profile right here is generally represents the shape of the river. And this profile that I'm showing you here on the right side, on the right corner of your screen right here, this is what we call as the longitudinal profile that represents the shape or the morphology of river. And you can actually see it as well on this picture right here. You can see that the shape of the ground is actually driven by the longitudinal profile of the river that flows in that region, for example. Okay, so again, longitudinal profile is the natural profile that a stream strives to achieve. All features are steepest near the source of the streams, right? That is something that I also need to emphasize here, that the slope of the longitudinal profile is much steeper here in the upstream region of the river. Compare that with the downstream part of the river, where it actually, the slope isn't very steep, right? And that's what characterizes longitudinal profile of a river. And a longitudinal profile of a river is actually typically ends up in a base level. It could be a local base level, such as lakes. However, in most cases, the base level, the ultimate base level, is actually the ocean. Okay, so you can see here, this is the ocean, and that would be the ultimate base level of a longitudinal profile of a stream. All right, another thing that I would like to mention here is that stream profile, again, in cross sections, they can look like a V-shape profile but they can also look like a U-shaped profile. If we take a look at the profile, and cutting it perpendicular to the flow of the river. Okay, so for example, this would represent a river valley right here that looks like a V-shaped river valley, and this V-shaped river valley characterize the streams or the river valleys near the source of the water, okay, or near the headwater. Whereas the U-shaped river valley that you see here, okay, the U-shaped river valley typically characterize rivers that are located near the base level of that river, such as the ocean. Again, still about base level, the lowest elevation of a stream bed can reach at a given locality. That is what that is the definition of a base level. And every single streams and rivers, they actually strive to actually erode the ground into or onto the level of base level. Okay, and I've already mentioned before that the base level can be local. If there are big lakes that are present in that region, it could be the local base level for the streams that are flowing in that region. However, ultimately, the base level of every single rivers on the surface of the earth is actually the sea level, okay, the ocean level, or where you have the beach. And base level can change and can evolve, and when base level changes, it could also influence the evolution of the morphology of the river. Here are some processes that could cause the base level to drop. For example, if we have an event where it actually caused the sea level to drop, therefore the base level also drops, and all the river processes and the carving of the river can be as deep as that new base level that just formed. And then uplift as a stream head, that could also cause the base level to drop, or draining of lakes, also another process that could cause the base level to drop. And here are the opposite processes that can raise the base level or increase the level of the base level, such as sea level rise, subsidence at the head, or formation of new lakes. So I think those are all the things, some basic concepts and anatomy of rivers and profile of rivers, and we're going to talk more about rivers and some other processes involved here and the surface runoff in the next video. So I'll see you there. Bye bye now.